Okay, let's suppose we had a differential equation that we wanted to solve, like this one, which says we have y double prime minus 4y prime plus 4y equals 3x squared plus x minus 2, and tells me that y of 0 is 1 and y prime at 0 is 2. Okay? How'd you solve this? Like, what do you start with?
Solve the homogeneous?
Yeah, perfect. Flip to the homogeneous solution because at least you'll get some of the points, right?
It's a repeated rule.
Okay, so make the associated homogeneous equation. Then
Go to the R's maybe?
turn it to r's. So you get r double prime minus 4r plus.
R squared, right? R squared,
Thank you.
Maybe it's
How about r squared minus 4r plus 4 equals
0.
0? Okay, so that factors into r minus 2 squared. Okay, so that tells me r is 2 or r is 2. Okay, what do I do with that information?
So y.
So y, which y am I talking about?
Y1.
Yeah, the homogeneous solution, right? Maybe part 1.
So we get two homogeneous.
Y sub h sub 1. Yeah, there's going to be two homogeneous solutions in these guys.
X e to the 2x. X e to the 2x. Or you could do
Okay,
e to the 2x.
x e to the 2. I don't know why you guys picked this one first.
I don't know. Just
Whatever.
said it x and then I had to finish it correctly.
Okay, so then we have yh2, which is
E to the 2x.
e to the 2x. And so my full homogeneous solution, right, is
X e to the 2x plus e to the 2x. Constants.
with constants, right? So I got c1 e to the 2x plus c2 x e to the 2x. Or whatever. Arrange your constants appropriately. Okay, then what?
Find a particular solution for the first guy.
Yeah, okay, so now I need a particular solution, right? So I need to put on my thinking brain, which is different than the one I usually wear around. So look at this jazz. That's a quadratic, right? Okay, so if you were left with that after differentiating a couple times, maybe multiplying by like 1 and 4 and adding stuff together, what would you probably start with?
Still quadratic.
Yeah, I think you want to guess a quadratic still. Does that make sense? Okay, so I'm going to guess yp is ax squared plus bx plus c. Just for kicks, should we add in an extra term here and see that it goes away? You want to try that? No? Okay.
What do you mean by that?
If you had like ax cubed plus bx squared plus cx plus d, you would see pretty quickly that that term's going to go away.
Sure.
Okay. So ax cubed bx squared cx plus d. This is too much, but it's actually a good illustration. So then, what do I want?
So equal to the.
Yeah, this should solve that, right? So to check whether this y particular solves that, what do I need to do?
Differentiate.
Yeah. Differentiate a couple of times. So yp is 3ax squared plus 2bx plus c. Right? And then yp double prime is
6ax plus 2b.
okay. Take that, stuff it in there, get 6ax plus 2b
Minus 4 times quantity 3ax squared plus 2bx plus c.
perfect, plus 4 times
Quantity ax cubed plus bx squared plus c.
cubed plus bx squared plus cx plus d equals
3x squared plus x minus 2.
3x squared plus x minus 2. Okay. Now, I'm going to do this the short way first. The first thing you should do is be like, yo dude, how many x cubes you got over here?
Yeah.
None. There are no x cubes over here. How many x cubes you got on this side?
Oh,
I got none here, none there. I got 12a x cubes. So 12a has to be, or sorry, 4a x cubes. So a has to be 0. Okay, so I'm going to scribble my a's out before I do the rest of this.
So we would equate it with 0x cubed, right? And then
Yeah.
solve for a.
So that part's gone, right? The ax cubed. That's gone because there aren't any x cubes on the other side. This piece
Also gone.
also gone because a had to be 0.
Okay, now I see why you want to.
And then
That piece also 0.
this piece also 0. So if you guess the right size, you're just not going to have any extra work to do. You guys see that? It's not a penalty, right? Like, wow, okay, it's a reasonable stance to call it a penalty. It's not impossible, right? You're not going to break it by adding more terms than you need. It's just going to be really annoying. So now what I do, since I've got this a little simplified, is just distribute everything through. So I got 2b minus 8bx,
4bx.
4 times 2 is, and a minus 4c plus, what do you get in the first thing when you distribute there?
4bx.
4bx squared
Yeah, so that was
Plus 4c,
this,
yeah.
right? Now I'm doing
plus 40.
these guys. So I got a 4bx squared plus 4cx
Plus
4d.
4d.
plus 4d. And that's supposed to equal 3x squared plus x minus 2. Right, so then you go through and you go like, start someplace. I'd start with the highest terms. So, you got 3x squared, where are your x squareds over here?
Just the 4bx squared.
Just the 4b. Okay, so off to the side, I write 4b equals 3. With that. The number of x squareds on the left side have to match the number of x squareds on the right side. Okay, then how many x's you got?
1. Negative 8bx and 4cx.
You got some x's here and some x's there. So it looks like I got negative 8b plus 4c equals 1. Beautiful. Then you go through and find your,
So 2b minus 4c plus 4d equals -2.
so those are all your constants. 2b, 4, minus 4c, and 4d. And what's your constant on the other side?
-2.
-2. And then the reason I'm doing this whole coloring nonsense is,
Make it easy to see.
yeah, and don't frickin' lose one.
Yeah.
Go through and check at the end, make sure you got them all. Right? If they're not all decorated somehow, then you missed that one. Go put it in your equation. So let's see, my constants were 2b minus 4c plus 4d equals -2. And then the good news is these systems are always pretty easy to solve when there's polynomials involved. When there's e's involved, they're a little worse. Right? But in polynomial land, they're pretty chill. Because, well, the power's reduced every time, right? So the high ones are only around for one equation. Right? So you got b is 3/4. Well, once you know b is 3/4, jam that in the second highest equation. Right? Figure out what c is.
Plus 4c.
Negative 6 plus 4c.
So you got -6 plus 4c is 1. So 4c is 7.
And 4 others.
C is 7, 4. Yeah. I didn't make this problem up.
That's not that bad.
And then
Jam all that into the last
take
one.
those two pieces of information, shove them in the last thing. So you got 3 halves minus 7 plus 4D is -2. So then convert to halves or whatever, get D is,
15 halves over 4.
oh shit, I guess I need this number, don't I? Minus 14 halves, that crap's a minus 11 halves. That's minus 4 halves. So I got 7 halves. So I think I got D as 7. Up to algebra or arithmetic error on my part. Okay, then what?
Then you know YP if you plug those in.
Okay, so then if I take those and trot them all the way back over here, oh, and I figured A was 0 a long time ago, right?
Mhm.
So go back over here, take those guys, plug them in. So A is 0, B is
3/4.
3/4, C was
7/4.
7/4, and D was
7/8.
7/8. Okay, so I took those, I brought them back, I shoved them in YP, then what?
Then you have to add the, yeah.
Yeah, so you have to get the general, so you take the homogeneous thing and the particular thing and what them together.
Add.
Stick, right? With the appropriate meaning of the word stick. Add. Right? So, in the end here, I think I end up with, oops, that one. I got most of that. I got the important part.
Is that because of the superposition?
Yeah, actually. So I got YH is, or Y altogether is YH, C1 e to the 2x plus C2x e to the 2x plus, and then you just take your particular solution, cram it in here. So you got 3/4 x squared plus 7/4 x plus 7/8. Okay. And now I am,
Solving the initial values.
yeah, solving for the initial conditions. Why didn't I solve the for the initial conditions when I got the homogeneous version?
It solves the homogeneous?
Yeah.
Yeah, because that's the wrong equation, right? Right, that was the homogeneous equation, not the equation you had.
Mhm.
Right, so now that you've got an actual general solution, now you want to plug in your initial conditions. So you should check y at 0, which is
C1 plus C2,
c1 plus
0, sorry,
plus 0,
plus 7/8.
and then 0 and 0 and 7/8. And that's supposed to be
1.
1. So that means C1 is an 8.
Sure.
And then if I do y prime at 0, oh god.
Well, you'll get
It's not that bad.
2C1.
Full addition.
Yeah.
And
Well,
then
you got a little bit of general.
Yeah, so I got a product rule right here, yeah?
Yeah.
Okay, but here I got
C1,
C1 times
2,
2 e to the 0 is 1 plus x e to the 2x plus a e to the 2x, right?
2.
Sorry, it's
Two.
2x e to the 2x plus e to the
That's plus 1.
So when I evaluate it at 0, I think I got just a C2 out of that piece.
plus 7/8 again. Or no, sorry.
And
Plus
then
7/4.
plus, this will be 6 over 4 times x. When I evaluate at 0, that piece is gone. This will be 7/4. And then what about the 7/8?
Gone.
That's gone when you differentiate it. Okay.
Equals
Okay, so, oh, I know what C1 is. C1's an 8,
Mhm.
right?
So a quarter.
And this is supposed to equal
2.
2, which is really confusing because I think
What is that?
2 times an eighth is a quarter, plus 7/8
So
is 2.
C2 plus 1 equals 2.
So I think I got C2 plus
2 or
quarter plus
Oh, 2, yeah.
7 quarters is 2 equals 2. So C2 is 0.
So do we have to go back and change our original y?
Uh-huh. So then we have to go back and change y again. Right, because this was the general solution, and then the solution to the initial value problem
Is that?
is y is, C1 was an eighth.
Mhm.
Sorry, e to the 2x over 8 plus 3 over 4x squared plus 7 over 4x plus 7 over 8. Right?
Yeah, that was totally easy.
Yeah, I mean, actually, there's nothing really terribly hard, right?
No, it's just a lot to.
Was there anything I did that was actually objectively hard?
At single process?
Keeping
no.
track of everything.
Yeah, it's just keep like, what's the next step? Like, which thing do I? Because man, if you don't know what to erase in this process, right? You get really lost really fast.
Are we gonna do anything later that's like hard, like partial fraction decomposition is like a pain in the neck sort of, like that sort of thing?
No, I would argue that there's nothing that's actually hard in differential equations except remembering what the hell to do. Like if you can keep it together and remember what to do, life is easy. Even when we get to probably the tank mixing problems are actually the hardest thing in here. The only other thing that bears any difficulty at all is Laplace transforming, and you just have to be a little clever and like stick to the algebra and remember partial fraction decomposition. But yeah, there's not a ton of stuff in here that's like really rad hard. There's just a bunch of it. It's all pretty different, right? Questions on this whole thing? No?